Chloe?
Alright,
Chloe? No, just kidding.
so we're gonna go ahead and continue. And we're gonna look at an analytical, an algebraic approach to the connection between a function and its derivative, okay? And we're gonna be able to determine where the original function was increasing, where it was decreasing, where it had horizontal tangent lines, where it had maximums, where it had minimums, all of that without the use of any graph, just by using a simple function that is given and finding the what? What do you think will give us all that information about the function? What could we use to figure all that stuff out? How would we know that the function is increasing?
With the derivative.
The derivative had to be what? Positive. How do I know that the function was decreasing? The derivative was negative. How do I know that the function had a horizontal tangent line? The derivative was 0. So what are your answers to all these questions that I'm asking?
The derivative.
The derivative is something, right? So what will give us all the answers to all those questions that I have? The derivative, right? Okay? So what we have to perform is something known as the first derivative test, okay? And using that derivative, we'll be able to find the intervals where it's increasing or decreasing. And when I said it, I meant the original function. And it'll also tell us where the original function has relative extrema. So what does that mean?
Maximum or
Where there's a maximum or a minimum, right? Okay. So we're going to perform the first derivative test. And we're going to find the intervals of increasing and decreasing and the relative extrema. Very simple. Should not take us too long, and then you should have time to do your assignment, which is only 3 questions. Okay, so it shouldn't be that bad. We're ready?
Yes.
So let's write down the 3 steps for the first derivative test. Right? The first step is to find, obviously, what we need, which is the what? The derivative of the given function, okay? And we're going to have to find something known as the critical numbers. Anybody know what critical numbers are? They're critical, yeah, you're right. Okay, so let me describe what they are. Critical numbers, okay, are where the derivative is equal to 0 or is undefined. Okay, so what do you think we're going to do after we find the derivative in order to find the critical numbers? Equal it to 0, right? Okay, now in all the cases that we're going to be working with today, that's all we're going to have to do, because the functions that we'll be talking about are all polynomial functions, therefore they will never be what? Undefined, okay? But later on, we're going to work with functions or derivatives that give us like a rational function, right? So now if I get a rational function with my derivative, okay, I have to equal it to 0, but I also need to find out where it's undefined. Okay, so when is a fraction equal to 0? What do I have to have for the answer to be 0 if I have a fraction? A 0 over a number, right? So when I'm working with a rational expression and I want to know when it's equal to 0, or the derivative, I would just have to set the what? The numerator equal to 0, right? Now if I want to find out where it's undefined, I need to set the denominator equal to 0, because a number divided by 0 gives me undefined, right? You understand? But we'll cross that bridge when we get there, right? For today, we'll be working with all polynomial type functions. Therefore, we won't have that issue of it being undefined, but that is the other case for the critical numbers, okay? I wanted to mention both of them so I don't mislead you. Good? All right. The next step, okay? You need to make a signs line for f prime of x, okay, using your critical numbers. Okay? To find the intervals of increasing or decreasing. We're going to make a signs line, and we're going to use that signs line of the first derivative with our critical numbers to find the intervals of increasing or decreasing. Okay? Yeah? You guys know what a signs line is?
Is it really named that?
Yeah.
Okay.
The signs line.
Sure.
No, it's actually called a sign line.
Okay.
But I'm calling it signs line.
Good.
Good. And the last thing is to write your answers using because statements. So for example, if you tell me that the function is increasing on this particular interval, you have to write because what? Because the derivative is positive, right? Or if you don't want to write all those words, you could say because f prime of x is greater than 0, right? Or we could say the function is decreasing because f prime of x is less than 0, or f prime of x is negative, okay, depending on how much you like to write. You understand? Okay, we always have to have our justification for our answers, and that's our because statements. Pretty good? You think we can do one? Alright, so let's find out everything about this particular function without its graph, with just the first derivative test. Ready? What's the first thing we gotta do?
Find the derivative.
Find the derivative. That should be easy now that we know the power rule. Unless you want to do it the old way with the definition, oh faithful. You want to do it? X plus h to the third minus 3 times x plus h minus x to the third plus 3x over h, and the limit is h equals to 0? You sure?
Sure.
No? It's all good? Alright, what's the derivative?
3x squared.
3x squared minus 3. Yeah, that saves a lot of time, right? Okay? So now, what's the next thing we gotta do? Find what? Critical numbers. So let's find our critical numbers, and how do we find those? Find out where the derivative is equal to 0 or undefined. In this case, this function can never be undefined, right? Because it's a polynomial. So since it can't be undefined, we're just going to find out where it equals to 0. So what do we get? Plus 3, right? 3x squared equals 3. Divide by 3. X squared equals 1, right? Square root, square root. What do we do when we take the square root? Plus or minus 1. Okay, don't forget to put plus or minus or else you're going to mess up. So we have our critical values, right? We have the numbers where the derivative is equal to 0. That means that these numbers, we have what kind of tangent lines? Horizontal, because the slope is equal to what? 0. There are possible places where I could have a what? A minimum or a maximum. I don't know yet. I would have to check some stuff, okay? In order to find that, we make a sign line. Okay? So step 2 is to make that signs line. AKA sign. Okay? Good? And it's of the derivative. So make sure when you draw your sign line, you label it as the derivative. The sign line is just like a number line. And on that number line, you're going to put your critical values. So what was the first critical value? -1, and your second one? +1. Put them in the correct order, okay? And we're going to test, because I want to know what are the values, or what are the signs of the derivative over here. What are the signs of the derivative in here, and what are the signs of the derivative over here? They're all going to have the same sign here. They all have the same sign there, and the same sign there. I need to figure out what those signs are. Okay, so in order to do that, I need to pick a number on this interval. So a number smaller than -1. What do you want to pick? -2? How about -100? Are we sure that that one's on this side? You think so? And we're going to plug that number into what? The derivative. Okay, so we're going to say 3 times -100 squared minus 3. Eventually you'll be able to do that check in your head, because all we care about is the what? The sign. Okay, that's why it's a sign line. Okay, so what would the sign of this answer be? Positive, okay? And what you're going to draw is a little line going up, because if the derivative is positive, the function is what? Increasing, it's going up. Okay? Pick a number in between these two guys. 0. Okay? Plug in 0. 3 times 0 squared minus 3. Again, plugging it into the derivative because it's a derivative sign. What do we end up with? Negative, so that means it's going what? Yeah, it's decreasing. Pick a number on the right side of 1. 100? 28? Whatever number you want, it doesn't matter as long as it's on the right side of 1. So 3 times 100 squared minus 3. What are we going to get there? Positive value, therefore it's, the function is what? Increase. Okay. So where is the function decreasing on what interval? -1 to 1. Okay, do I use these points in my interval? No, these are just what? Test points. Okay? Where is it increasing? -infinity to -1. Not -100 to -1. Right? I'm leaving stuff out if I say that, okay? This is just my test point. Okay? Where else is it increasing? 1 to positive infinity. Understand? Where would I have a maximum? -1. Doesn't it look like a maximum? Going up and then coming down. So there has to be a max there. And there has to be a what? A min where? At 1. Okay? The correct justification is because the derivative is changing from positive to negative. And here we have a minimum because the derivative changes from negative to positive. I think that's a lot easier to interpret than looking at the graph. Sometimes the graph is confusing when we read it, right? So I really like the analytical approach. Okay? So let's go ahead and write all that stuff down. Okay? So we can say f of x is increasing on what intervals? -infinity to -1 union to infinity, because this is step 3. We're writing our justifications. Why? F prime of x, the derivative, is what? Greater than 0 or is positive, whatever you want to write. This is my way of saying that it's positive. Good? F of x is decreasing on what interval? -1 to 1. Tell me why. Is less than 0 or is negative if you want to write it out. Your choice. Good? What else can I tell from the sign line? Where I have maxes or mins. So let's write that down. F of x has a relative max at what point? -1 comma, we're going to write the whole point, okay? Because if we would have read the directions like we should have, it was asking us to find all the what? Coordinates, right? So when it says coordinates, we want the x and the what? And the y. We only know the x, right? In some cases, some problems, that's all they ask for. So if they ever ask for just the x values, you're done. You have them right there, right? Okay, but here they're asking for the coordinate. So if I know an x, how do I figure out the y? Plug it in. Which equation, Daniela? The original equation, right? Because that gives me points on that graph. Okay? Alright, so let's finish it off and then we'll find the y value, okay? So why is this? What's the because for this answer? What? The derivative is equal to 0? That's not the only reason. The derivative does not change from increasing to decreasing. The derivative changes from what? From positive to negative. Could I say f of x changes from increasing to decreasing?
Yes.
Yes, right? F of x. And I can base that off of the derivative, right? The derivative is positive, the original function is increasing. You understand? So be careful what you say. There's several ways of writing the correct answer. Good? Did f of x have a relative min? Where did it have a relative min at?